In this tutorial, you are going to see how to use the tool mode in Godot to draw and run code in the editor to enhance your level design experience. We're going to use the real-world case of a moving platform that has to follow waypoints that you can see here is drawn in the editor. I'm not running the game and the platform is following the waypoints. You will learn to draw in the viewport and in the editor directly using the draw method on Node 2D. You will see that with Godot you can run gameplay code in the editor, you almost don't have to change anything, and you can use that to change the speed of your platform and to preview how your level will play without launching the game. I will also show you how I built that flexible waypoint system that you can use not only for complex paths, but that you can use for horizontal moving platforms or for vertical ones. This is an intermediate level tutorial. If you've never heard of Godot's tool mode, you'll want to check our collab with Mike from Games from Scratch. But without further ado, let's get started. We're going to start with the waypoint system, which is split into two components. On the one hand, you have the waypoints, and on the other hand, you have the moving platform. The moving platform just moves where you tell it to move, and the waypoint system is going to provide the next point the platform should move to, the active point, which is part of a list of points that you have as children of the node. I'll open the moving platform scene, and note you can find the source in the description on our repository as usual. The moving platform is made of a kinematic body 2D node so that a playable character can stand on it. It has a collision shape so that things can collide with it, and the drawing is based on the extent of that shape. So if I hide the moving platform and unhide it, you will see that it updates the drawing to fit the collision shape. I use drawing functions in Godot quite a lot for prototyping, and these are quite convenient, so you can use some calculations to draw a rectangle based on your collision shape. Lastly, you have a timer. The timer controls for how long the platform will stop on a given point on the waypoint. You could have the timer on the waypoint system, decided to put it on the platform. The choice is up to you. Now let's jump onto the script to see how this all works. First, you want to have access to the nodes that you are going to work with. There's the wait timer at first, and then the waypoint nodes. The waypoints node is going to use a path, an empty node path that we export to the editor. This is what I showed you in the intro, the tool we use to connect the moving platform with the waypoints node. You could have the waypoints node as a child of the moving platform, but this makes the drawing code a little harder to manage, and it forces you to work with the global coordinate system instead of the local one. This is why I went with the node path approach, which also has its drawbacks. Then the last two variables, I think are in this order in the final script. Our editor process, we'll see that a little later in the tutorial. This is how you can toggle the processing in the editor on and off, and updating the drawing on the waypoint system, etc. And you have the speed, the movement speed of the platform. Lastly, I keep track of the target position the platform should move to. When the platform reaches that position, in physics processes we'll see, it waits a bit and then it will request a new position from the waypoint system. In the ready function, to avoid some bugs, if there is no waypoints node, because at first the waypoints path will be an empty node path, preventing us from getting the waypoints node, I will set physics process to false to make sure that the node doesn't try to access the waypoints data, and then end the ready function here. However, if we have a waypoints node, as we should, then I will place the platform at the start position that the waypoints node will give me, so using a method I defined there, and I will set the target position variable. I will initialize it to the next point on the waypoint system. Next up, let's look at the movement code. For that, I use the physics process function. Not only that, the kinematic body 2D itself is set to synchronize to the physics in the inspector. First, we have some of the usual calculations to calculate the motion for the node. We calculate the direction the platform should move to. A vector pointing from the node, its position, to the target position. We normalize it. This gives us a direction vector. Then I calculate the motion, the entire distance in a given direction that the node should move this frame. It's the product of the direction vector times speed times the delta time provided by physics process. And then I don't want the node to overshoot the target point, so I want to calculate the remaining distance to the target to make sure that I can stop the node at the target point very precisely. And that's what we're doing in the next block of code. If the length of the motion vector, so the total distance the platform is going to move this frame, is greater than the distance to target, then we place it at the target position, the target location. We update the target position to be pointing to the next point in the waypoint system. We temporarily stop physics process and start the timer that we had here in the scene tree. It has a wait time of 1 second and it's connected, and its timeout signal is connected to the moving platform. So at the end of the timer, I'm going to go to the bottom of the script to unfold the callback method. We set physics process back to true. This is everything we have to do. Back to the physics process method. If the motion vector's length is not greater than the distance to the target, we just add the motion vector to the current position of the platform. This is what moves the platform progressively every frame until it reaches the target. Next up, let's look at the waypoint system. You have a starting point as a child of it, as a position 2D node. I'm using these nodes because they give you that little crosshair that indicates nicely where a given node is in the level. Then if I start to duplicate the start node and I add a few more, you'll see that the node is drawing lines and triangles to indicate the direction and how the platform will cycle between the points. So that is all you have to do to use the waypoint system. Then everything is in the code. There is a bit of code for drawing in there, a lot of code actually, but we're going to look just at the waypoint system first. It relies on one private variable, the active point index. This is an index that corresponds to one of the child nodes in the scene, one of the position 2D nodes. Then you have three methods that are going to be used by the platform. You have getStartPosition is going to return the global position of the first child. Note that we are working with the global coordinate system here. Then getCurrentPointPosition is going to get the child corresponding to the active point index and return its global position. And finally, getNextPointPosition is going to increment the active point index, and we make sure that if it reaches the end of the list, the last point in the list, it's going to loop back to the first child, to the start one. So for that, I use the modulo operation, which returns the remainder of a division, and I use the getChildCount method to get the number of children under the node. In this example, when the index value reaches 4, which is the number of children in the waypoints node, it goes back to 0 to the start node. And this is all you need to make the platform movement work and the waypoint system work. You just need these three functions. It's very simple. Now, you won't know in which direction the platform is going to move without previewing its motion. This is why it's worth sometimes investing a little bit into that drawing code that in the context of a big project, you're going to do a lot more level design than coding these simple things like drawing lines and triangles. That's going to save you time in the long run, so you don't have to see the platform moving to know how the level design is going to work, roughly. Note one thing, it's that for the system to work, you have to set the waypoints path on the moving platform. So for that, you assign a given node to that property. You want to select the waypoint 1. Then on top of that, you want the waypoint node to be before the moving platform in the tree. That is because if I go back to the moving platform's code, in the ready function, we return and we deactivate the platform and there's no waypoint node. And in order to get that node, we need it to be ready and to be instantiated before the moving platform. This is the limitation I was talking about with node paths. As far as making the platform move in the editor, the only thing you need in the script editor is to add the tool keyword at the top of the script. Only with that you will get the platform moving in the editor. Now, in my example, I have one little addition. It is this line on line 8, the editor process property, and that I'm using on the waypoint and the moving platform, and that I would use on multiple nodes that are going to run code in the editor. This is a Boolean value that's exported to the inspector so that when I select the moving platform, I find it at the top and I can set it to off to stop the platform, back on to make the platform move. Note that the value is true by default. This is why the platform was moving at the start. Seems it's a little buggy at times as well. On the waypoints node, in the final script uncommented, you will find the same property. But if I go back to the script, this one goes through a setter method. This one is around the bottom of the script. It's called set editor process. It's going to set the value and it checks if we are running the code from the editor. For that, you use the engine singleton and you access its editor hint property. If this value is true, you are running the code from the editor. If the value is false, you are running the code from the game. That is why, while checking, if we are not in the editor, we return from the function. We don't want this property to do anything in the game. Otherwise, if we are running from the editor, we use the value to toggle physics process on and off on the node. Note that I forgot one thing which triggered the bug that you could see right before in the video. It's that we want to stop the wait timer because I'm turning physics process on and off, but the onTimer timeout method is going to still get called. It's really a detail. You shouldn't mind these tiny bugs running in the editor because you are only using the tool code for visualization purposes to help you with the level design. So if there are small bugs, as long as you don't run that code in the game, which we're not doing here, you shouldn't bother too much. And now we get to the last part, drawing on the waypoints node. First, I want to show you that there is quite a bit of code related to that in this version of the script. Allow me to make some space for you so it's a little easier to understand. But before you start to think that this is too much code, first, it doesn't take that long to create. Second, you are going to reuse some of that code throughout your project. So if the production takes 6 months, for example, or if you go from project to project, you can reuse libraries of that code. And third, if you are doing a lot of level design, it's going to save you time, as there are things like, for example, what if one point is not in the order you think it is, like you can see on the screen here? Well, having the path drawn and the order in which the platform is going to move tells you instantly that there's something wrong with your level design. So you don't have to wait for the platform to move in the wrong direction to see that. And this is why debug tools are worth investing a little bit of time. Now, let me give you an overview of the code. So first, we have the editor process exported variable at the top of the script. I want to mention one thing, going back to the game scene. It's that having the same property with the same name makes it so you not only have it at the top of the inspector, but when you select different nodes that have the same property, you can toggle it on and off on all of them. Editor process for the waypoint system is only going to trigger drawing on and off. So it's going to allow or prevent the drawing to update. It's more about showing you that when you select the two nodes, you have the same property there. And so you could have tool code for many nodes in your scene and activate or deactivate it on all nodes really fast by selecting them all at the same time. Now back to the waypoints code. The next lines export some values so that you can change the drawing color and the line width of the path. You can export as many of these variables as you want. We are here to help the designer change the lines color to make them pop a little bit. Let's say if there's a lot of complexity in your level design and this doesn't pop enough. You can increase the line width as well to make everything look a bit thicker. And the next methods I want to look at are ready and process. They are fairly simple, but once again, if we are running the code from the game, so we are not in the engine, in the editor, we set process to false. We set process to false because the process method is what is going to draw the node, what is going to draw the path. The update method is available on all canvas items. It's a virtual method that you override and to draw stuff on the canvas. Now it also has that update method, another method that you can call manually to update the node, and it will redraw it at the same time. So I'm redrawing the path on every single tick. This is what makes it so when I move one of the points here, the drawing updates instantly. And you might think that for optimization or something like that, you might not want to redraw all the time. When you are running the game and you are moving a sprite or the camera, or you are redrawing everything almost all the time. If you are running a shader, it's drawing 60 times a second. So you should not be worried about that. Then the tough one is going to be the draw method. So let me run you down through it. First, we safeguard the drawing a little bit. So I want to check two things. That first, if I'm running the code from the game, I'm going to not draw anything. This is how you get the platform moving in the game, but you don't get the path to draw, because Godot will automatically call draw one time on every node that has this draw method defined. The second thing is, if we only have one child, we are not going to draw anything because we don't have enough points to draw lines. Next up, we want to have some variables to store everything that we are going to draw. So we're going to first calculate all the points, the polygons, etc. that we want to draw, and then I group the drawing at the bottom of the function to make it a little easier to read. First, the points. The points are going to be what we use to draw the line. The triangles, I'm going to store them in a simple array, and I created my own function to draw triangles that are rotated in the direction of the line. Finally, we have a last point local variable that we are going to use to store previous point in the loop. We are going to loop over all the children in the waypoints node. You're going to see that in a second, what we use it for. So the first thing we do, we loop over all the children in the node, all the position to the node under the waypoint, and we append the position of each of these to the points array. This is all we need to draw the line, almost. Then we want to do a little check. If we reach the second point, we are going to be able to get the center between 2 points, and we are going to use that to draw triangles. So we calculate the center between the current node's position and the last point. Note that the last point, it's going to come right after that. I'm going to add it right there. from the second point onward, we are going to mutate it and assign the last position to this position to it. Then we calculate the angle between the previous point and the current child in the loop. And for that, last point being a position, it's a vector2 value and has an angle 2-point method. This is the method you use to find the angle between the horizontal axis and a point. Then I append a dictionary to the triangles array where I store the center and the angle of my triangle, two pieces of information I need to draw them. The angle is the angle of the tip where it's going to be pointing. After the loop, we append the first child, once again its position, to the points array so that the line draws back to the beginning instead of stopping at the last child. And finally, we have our drawing code. For drawing, we're going to, the first one is draw polyline. It's from canvas item, I think, and it's going to take a pull vector2 array of points and a color, use that to draw a line. Then for each data point, each entry we stored in the triangles array, we're going to call a method called drawTriangle that I coded myself. It takes the triangle center, the angle, and 2 times the line width, the radius of the triangle if you want, to draw an angled triangle. I'm going to go down to the bottom of the script to show you how this method works. To draw the triangle, we're actually going to draw a polygon. This again is a method that's defined on canvas item that takes a pull vector2 array of points, a pull color array of colors, and it's going to use that to draw the polygon. I create 2 values, points to store the 3 vertices of the triangle, colors, a pull color array that contains only 1 color that you have to wrap in an array to convert it to that special type. It's an optimized array for the color type. Then I'm going to loop over 3 points. I use the range function in GDScript for that, and I is going to take the values from 0 to 3, in this case, 3 excluded. So it's going to be equal to 0, 1, and 2, the index of each vertex in my triangle. I calculate the angle of each point. I'm using pi and these values because I'm working in radians here and not in degrees. The offset variable is going to calculate the offset of the point to the center value, the center of the triangle. I use the cosine of the angle and the sine of the angle multiplied by the radius of the triangle, and the final point, the final vertex that we're calculating, is the center of the triangle plus the offset to the center for each vertex. We append the point then to the points array and use that with the draw polygon method. This in turn is what's going to draw what you see on screen here. It draws only 3 triangles because I did not bother to add the last one in the code, but you can add it, of course, and it's going to draw the polyline that connects back to the beginning. You can simplify the drawing process by using some built-in nodes in Godot. I've covered them in my prototyping video for the Metroidvania Hook project. You can find that in the description below. There is a node called Line2D that you can use to draw lines in Godot. I'm going to show you that. I can tap to create the points, and the points property is a pull vector2 array, so you can set that via code as well to draw the points. Now the reason I'm not using that node is to kind of encapsulate the waypoint system for the designer who's going to use it. As the designer, you only see these nodes in the scene tree and the drawing works. You don't have an extra Line2D node or triangle nodes that are going to add unnecessary information in the scene tree. Then note that instead of using functions to draw the triangle, for example, by hand, you could instance a sprite node from the code and use it in the draw function. Now, the draw triangle method might seem a little daunting at first, and the draw method here, but again, this is the kind of code you're going to code once and you're going to reuse throughout the lifetime of the project. If you have experience doing art and you can quickly get the sprites into the engine, great. Use an SVG file, for example. But if you mostly do development, sometimes it takes less time to code something like that than to open a drawing program and to draw a clean triangle, scale it to the right size, etc. Here's a little bonus about this system. You can make it work for horizontal, vertical, diagonal platforms. The number of points doesn't matter at all in this system. So you're going to use 2 points, and to align them, you can use the grid with snapping. So you want to click on the little snap icon there and configure the snap so that you have a pretty big grid step, let's say 40 pixels in this case, so that you can really easily align the points. I'll move the starting point as well and snap it to a node. As long as you align the nodes like that, you're going to get your platform to move horizontally or vertically. Note that I haven't coded the platform to update as soon as we move the node. You would have to update that code yourself. Another option to align the nodes is to use the rulers for vertical and horizontal alignment. You can use that instead of the grid if you want. One question you might have is, why bother doing that and not use the debugs, sync scene and script changes options? Options that allow you, when you run the game, you can go back to your scene, modify things, you save, and the waypoints will update. You will see the platform doesn't go to the rightmost of the viewport here. So you could use that. Even if you have only one screen like I have, you can pin the window. So you right click on it and you make it always on top. And then you can go in the editor and you can change things on the side like so. Save to update the changes. And well, the first thing that you can see is you will have to add some code to draw the path in the game and make sure that this code is not accessible to the final players. Using the tool mode, you ensure that you have code that will only run in the editor and should not run in the game. And if you were drawing only in the game, you'd have to move the node and press Ctrl S to save every time to see the path update in the game view, which you don't want to have. More importantly, having this drawing code in the editor, I don't need to have the moving platform. I not only don't need to have it moving, but I don't need to see it at all to know how it will move. On top of that, if the game is a bit larger, I don't have to launch the game every time, which might take 1 second or 2 seconds to load if the project is really big. Instead, I can just keep working in the editor with the scene and work as fast as possible, focusing on the level design. This brings us to the end of this little tutorial in which we've seen how to draw in the editor, how to run gameplay code in the editor using Godot's tool mode, and we've also seen how to create a moving platform with a waypoint system. A little challenge for you, you can find the source code in the video description. There's one big improvement that you can make to it. It's not having that separation and the need for the node path between the moving platform and the waypoint system. And you can do that in a few ways. You could have the waypoint platform node create the moving platform as a child of it at runtime, or you could have it the other way around. Add a waypoint node as a child of the moving platform. A little hint, if you want to do that, there is a method called setAsTopLevel and canvas item that you might want to use for the waypoint system. It will allow you to draw it globally somewhere on the canvas, but it adds a bit of complexity to the code as well if you want to do that. If you want to go further, I invite you to check the videos in the description. You can check our plugin tutorial from the OpenRPG project. That said, I want to thank you kindly for watching. Please tell me in the comments if you like this tutorial, if you like the structure. I've tried to take into account the feedback you've given us on the recent forums. It's the first iteration, adding an intro with the teaching goals, adding a quick summary at the end, talking about one or two pitfalls in the video. So I'd like to know if you noticed it and if it makes a difference at all. That said, be creative, have fun, and let's see one another in the next one. Bye-bye.